Hi everyone, thanks so much for joining us today for our webinar Development Swarm Cluster with Docker Compose version 3. We're really excited that you could be here. Just a few announcements before we get things started. The webinar today is being recorded, so everyone will receive that in a follow-up email over the next couple of days. Also, we will have time at the end of the session for questions, so if you have any questions either now or during the presentation, feel free to type those in the questions box in your GoToWebinar control panel, and we'll do our best to get to those after the demo. And finally, at the end of the webinar today, you will be prompted to fill out a short 30-second survey. It really helps to get your feedback and how we can make these webinars even better in the future. So if you could take just a second to fill that out, we would greatly appreciate it. All right, well, with that said, I will pass things over to our presenter, Alexei.
I'm going to share my screen. Okay, hello. Today I'm going to talk about how you can build a development Swarm cluster on your laptop, on your machine, using technologies you have, using Docker, native Docker or Docker for Mac and Windows, Docker Compose version 3, and Docker. About me, I'm a Chief of Research for Codefresh.io. Codefresh is a continuous integration and delivery service for based on Docker, and also every step and pipeline composed from Docker containers. So we with Docker from the very beginning. I also have several open source projects which I contribute and lead. One of them is Pumbaa. It's chaos testing. It's like chaos monkey, but for Docker containers, where I can simulate different failures and network emulation failures. For last 2 years, I'm working with Docker, Go, AWS. Welcome to visit my blog and follow me on Twitter. I publish there from time to time interesting stuff. So let's start with Docker for Mac and Windows. What is it and how it's different from what we have before? So before Docker team created a Docker, the idea behind Docker for Mac and Windows was to create native feeling Docker like you have when you work in a Linux environment. Okay, in Linux, Docker is a regular daemon. You work with it using a command line or API. But for most end users, your laptops you have Macintosh or Mac OS or Windows installed. So the team, at the beginning, there was a workaround where I can create run Docker and virtual machine, and then, connect this properly, set up the networking, and mount needed volumes, and actually you can access this Docker. You have a different distribution, like a boot to Docker, and later on, Docker machine was released. So also simplified the machine creation. But actually, Docker for Mac, with Docker for Mac and Windows, you don't need this, okay? Out of the box, they provide easy installation and setup, actually single install through Homebrew or just a Visual GUI installer, and you have full Docker development environment. You have actually have a Docker client, native Docker client. You have Docker daemon running inside a small virtual machine, Linux or Windows. You have a Notary, you have Docker Compose, so you have everything you can start to work with. Okay, it's under the scene. The Docker daemon still runs on use native OS virtualization. For Mac, it's X-Hive project, and for Windows, it's Hyper-V. Running some custom minimal Linux distribution based on Alpine. You have seamless volume mounting for code and data, including iNotify file notification. That allows you to fast edit test cycles. You don't need to stop and start your virtual machine to modify VM settings and expose host volumes, etc. So it's much easier and transparent. Okay. Excellent network support, which out of the box you don't need to configure the Docker daemon running in VM to work trustworthy with your VPN and proxy, especially if you work in corporate and you're behind some some VPN or some proxy, enterprise proxy. Okay, so if your network is working, Docker will work also, which was not the case when you worked with a virtual machine. Okay, and another nice thing is, it's totally transparent and it's easy to use, and it's work pretty fast. And you also have when you run container and you expose port, you address this container like it's on localhost, while still it's inside the VM. So you don't need to know what's your VM IP. Actually work with a localhost address. With Docker for Mac, it's even support a multi-CPU architecture like ARM, MIPS, PPC, and other. And actually, it allows you to run Docker images that has binaries compiled for this architecture, with Linux distribution for ARM and binary compiled for ARM, and you can run it on Mac. Some nice feature, especially if you work with IoT. Let's talk about Docker Swarm mode. Docker Swarm mode was introduced a year ago, maybe more, with Docker 1.12. Okay, before it, Swarm, it was possible to create Swarm using some key value store, and Swarm is actually a cluster of Docker machine where you have one or more Swarm masters and you have multiple worker machine. You would like to link them together into a single cluster and be able to deploy your application on this cluster. Okay. So before Swarm mode, you needed to create proper certificates and key and install console discovery service and start console agent on each machine, and properly to set up all these certificates and launch get APs of nodes and launch each node with a lot of parameters to properly connect and work in the Swarm cluster. It was possible, people done it, but it was kind of headache. And with a new way, it's pretty easy. It's just you run Docker Swarm init on master machine, you take the token, it's some UUID token, and on other Docker machine, you run Docker Swarm join command, passing the token, and that's all. Actually combine both machines into the cluster. You don't need to install a console or etcd as a key value store, since Docker itself implements a Raft consensus protocol to internal synchronization between the node and the master selection in case of node fails. And the way to deploy the application, actually there is a new command with Docker 1.13. Starting from 1.13, you can deploy the Docker compose file that describes your composite application and deployment properties using simple command called docker stack deploy. Pass the compose application, provide the any name you like, my app, and suddenly your application being deployed and connected in separate networks. Each service is automatically discoverable, and each service run a number of replicas as you want. So it's just one command. Pretty easy. Okay. What is the difference between Docker Compose app and Docker Stack Deploy? Okay. Actually, Docker Compose, Docker Client and Docker Compose, these are two different applications. A Docker Client also has a built-in parser for Docker Compose format. Okay, it knows how to read this Docker Compose format. It also reads the new deploy section, which was introduced with version 3 of Docker Compose format. And know how to deploy this, what is described in this section on Swarm cluster. So you can use this your Docker Compose to deploy Compose application on the Swarm cluster. Before it, there was an option to create a special JSON file called DAP, Distributed Application Bundle, which was possible to create from your Compose file, but it didn't support all features. Right now, it's kind of feeling that they are going to abandon this format. Docker Compose application, CLI, command line tool, is a Python-based application that also understands Docker Compose YAML version 3. It has its own parser implemented, but actually totally ignores the deploy section and doesn't know how to deploy Compose file on Swarm. It works against single Docker host, and actually Linux, for each service you have only a single instance of each service, and they are all linked together with basic network. With Compose file, the network is overlay network, which actually span multiple nodes. Okay, this is the core difference. Actually, Docker Compose command line see only half of the Compose file, and if you like to use it both for testing and for deployment, use Docker Client. You don't need Docker Compose anymore. Before Compose version 3, okay, before Compose version 3, which was introduced with Docker 1.13, actually you can do the same stuff. You can do deploy, could create services and network and overlay networks and volumes on Swarm using commands, using Docker client. So you had a service create command and network create command, a lot of switches. So, and usually people used shell scripts or Ansible or Chef or Puppet, different automation frameworks to deploy application on Compose application on this on Swarm, and you had a Compose file to run the composition locally and separate totally different automation script to deploy it on Swarm. Right now, it's the same file where you can run it locally and you can deploy it on Swarm. Actually, all flags, all attributes, you can pass the command line to the service create command and network create command. You can right now to define in nice and readable YAML file. Okay, and this is the main difference. Compose v3, they introduced a new deploy keyword, deploy key under service node. Under service node, you can specify how this service is deployed. Okay, you have a mode where you can say if this service is going to be a global service or replicated service, meaning if it's global, it's distributed on on every Swarm node. And if it's replicated, you define the number of replicas, how many instances of this service you would like to have. And once you have several instances, actually built-in DNS server doing basic round-robin distribution of your traffic, DNS-based distribution. When you ask for IP or when you try to address the service, you get random service from Swarm. Okay. The placement constraint, where you can define where your service is going to be placed. You can specify node ID, which is Docker host node ID, or host name, or host role. For example, it can be a manager or worker, or label. If you run your Docker with have labels, you can use these labels, for example, to select most suitable nodes to run this kind of service. For example, you have nodes that has more RAM or better CPU, you can select specific services to run on these nodes, Elasticsearch service. Or you can also use the engine labels, meaning when you run your Docker daemon, you can also specify labels for the daemon. So when you deploy a service, you can select the daemon based on these labels. It provides you a lot of flexibility how you would like, which resources you would like to allocate to which services. Update configuration, it's possible when you update your compose file, for example, you modify the deployment section or you modify the image you are using for your service, your next version of image, and you run stack deploy command again, it's not going to create a new stack, it's going to update only modified items, modified services. And you can also specify how this update should be executed. You can specify the parallelism, meaning how many replicas simultaneously will be updated. For example, if you have 10 replicas of some service, you can say, I would like to update 2 at a time, okay? And you can specify the delay between updates. You update 2 at a time with delay of 15 seconds. So in next 15 seconds, you will update next 2, etc. What to do on failure actions. How many times you're ready to accept failures, for example, to retry. And monitoring. Monitoring, it's a timeout to decide if service is up or it's failed. Okay. Resources, you can limit resources like you can limit with Docker run command or Docker service create command. You can allocate a CPU shares for your service, so CPU quota or specific CPU set, memory limit of RAM memory or swap memory. Okay. The restart policy, what to do if a service fails, okay? If it will automatically restart or will be restarted on failure, what is the delay, maximum number of attempts to recover from failures, window. And also labels, you can specify for each service labels that can be used later. In our demo, I'm going to show demo how you can create the Docker Swarm cluster on single machine with native Docker. If it's Linux, it's native Docker. If it's Windows or Macintosh, it's Docker for Mac, Docker for Windows. And I will use, as a master, I will use my current Docker. And as a worker machine, I will use Dint, which is Docker and Docker, meaning running Docker containers that contains Docker inside, okay? And these 2 Docker containers with Docker and Docker, I will join them to the master. So I'm starting the master, And I'm also start a Docker registry in the mirror mode, meaning it just to speed up things, that every other Docker daemon running on my machine will fetch their images through this mirror registry. Meaning if one daemon fetch Ubuntu image, the second daemon will get it from mirror and will not fetch it from Docker Hub. Just speed up things. To run Docker daemon, Docker in Docker, you need to run the container provided by Docker team. It's called dint container in privileged mode. That's all. And expose it port to allow access to this container. Let's see the demo. Okay. So I have a small I'm going to run the swarm of 3 nodes, one master and 2 workers. I'm going to deploy the voting application on this swarm cluster. So I start init swarm. The first command is docker swarm init. As you see, it returns also the swarm token that should be used in order to join this swarm master. Then I take this token into environment variable. I get the swarm master IP, something that I need to pass to Docker worker. And I run docker run command with for registry to create a mirror registry. And then I start the first worker, dint container. So it's run in privileged mode. I pass to it the mirror and I join it with the token and Docker Swarm master IP to the Swarm cluster. Okay, this node joined as a Swarm as a worker. I do the same for the second container and the second node joined to the cluster. Okay, if I run right now, we'll run docker node ls. Actually, the command that shows me my swarm cluster. I can see that my swarm cluster consists from one master leader and 2 worker nodes. Okay, and all of them actually are running on my machine within single VM, single Docker for Mac VM. Okay, the master is the Docker daemon, and 2 workers are regular Docker containers. Let's see how it looks like. So this is my swarm cluster. You can see 3 nodes. Each of them has 8 GB RAM. They share the same RAM. Okay. Let's go and deploy the application. As I said, it's single. Let's take a look first on application. It's version 3. You can see you have services, Redis and Postgres and worker and voting application and result application. For each service, you can see also there is a deploy section where it's going to, for some I specified more attributes, for others less. For example, Redis, I'm going to run it on manager. I put a placement constraint to run it on manager node. And DB, it's also run on manager node. Voting up, I said I'm going to deploy it replicated mode. And I would like to have 2 replicas and would like to run it on worker. And result application, I didn't say anything, so it will run randomly on some node. I don't care. And worker application, actually, it will be run, it will be replicated again. And I put some resource constraint, hard limit and reservation, memory and CPU constraint. Also define the restart policy, what to do when application fail, update, etc. You see I have here network and volume for data. So let's go and run this, deploy this application on our Swarm cluster. Okay, I'm running Docker stack deploy. I provide this compose file argument called vote. This is the name of my application, and I start to deploy it. Okay, you can see it in command line. You can also see it in Swarm visualizer. Actually, it's the same. And as you can see, the nodes being deployed and they are running. The preparing status means that currently image being downloaded, and once it's downloaded, it will begin to run. Okay, and also you can see that the placement constraints are respected. So vote, as I wanted my vote database and Redis to run on manager node. Okay, they both run on manager, and worker and voting application and result application, all of them running on worker nodes. Actually, result application said I want to run randomly, so it selected the worker node, one of the worker node, and as you can see, all of them are now green. All of them are up and running. Let's see this application. If someone didn't see it on different presentation, let's take a look at it, how it looks like. So I have voting. Okay, it's a simple voting application. I can vote for cats or dogs. What's interesting, you can see the worker that processed the vote. It's processed by container ID. It's down there on the cats versus dog page. So I vote for cats, and you should see that 100% votes for cats, and the container ID changing from time to time to different worker. Depends who is taking responsibility for this vote. Okay, so what we've created a Swarm cluster on local machine. We have prepared a compose application, Docker compose file, and deployed the compose application on this machine. Okay. Switching back to the presentation. The demo itself is available on GitHub, all files, so we can see how actually all commands that I used to create the Swarm and the compose file itself, so you can go, clone it, try by yourself. It's pretty straightforward. Okay, it will work for Mac since I have some shell script running this command, but I believe it can be adapted to run on Windows pretty easily. So right now, if you have questions, you need to fill them in. And I would like to add something about Codefresh. Codefresh, as I said at the beginning, is the continuous integration and delivery platform for Docker. Besides being able to, to compile and to build, to create your images on commit or on pull request, automatically we are also able to run your composition. So for pull request, for commit, for branch, whenever you want. You can build all images to create pipeline that takes your Docker file, create images from this Docker file, then takes other Docker file, execute your test, integration test or unit tests, and you can run this integration test against a real composition using Docker compose file. And this week we are going also to support Docker compose version 3. Okay, I'll take a look at the question.
Yeah, we have one question, Alexei. The question here is, what if a node fails? What will happen to services deployed on that node?
Actually, it's a Swarm responsibility. The scheduler of Swarm will take, it will not repair your application, of course, but it will try to create the same number of replicas as you wanted. So if there was some unique service running on failed node, it will be launched on a working node, on another node, okay? And if you wanted to have 10 replicas of your service and one of them failed because of node failure, it will be launched on any working node. Currently, it will be a new launch, meaning if your process had a state and was working on some request, so you need to design your application in such a way that your service might disappear suddenly, and you need to be able to process the request or somehow mark that this request will need to be served once again. But what Swarm promise you, it promises you a number of replicas of your service being available.
Okay. So Sam here asks, what would you recommend in terms of the best setup to run this under AWS EC2 instances?
Okay. Actually, there is nothing, nothing special. If you use AWS EC2, it's better to have the VPC for your Swarm cluster, okay, and to properly configure security groups, which are application firewall. But beside that, these are VM machines. So on this VM machine, you need to have your Docker being installed. Take a AMI image with Docker, select which one you like, Ubuntu, CoreOS, whatever. And then you need to create the Swarm cluster, meaning run at least 3 or more Swarm masters, odd number of Swarm masters, and Swarm workers to create your environment. With EC2, of course, it's much easier to create a dedicated or to allocate a special machine for special services, for example, to get bigger instances with more CPU or more memory depending on service you would like to run there. So it's pretty nice. Okay, let's go to the next question.
Let's see. How do you use multiple nodes with this? You explained how Compose works only on one VM and Swarm on multiple nodes. Can you elaborate how this can be adopted to work on multiple nodes?
Okay, good question. Actually, what I showed right now, it was Swarm cluster with multiple nodes. Okay, the fact that it run on single VM, it's indeed. But what happens that I have 3 different Docker daemons, and I connected them together over this overlay network. And from the point of view of Swarm, it's 3 different machines. Okay, they're all together running in same machine. It's okay, same VM, or in case of Linux, it would be even the same operating system. But from Swarm point of view, these are 3 different daemons, and it works with same if I will run these daemons in each daemon in its own virtual machine on same physical machine, or on different physical machines. It doesn't matter. It will still work if you have network connection between this machine.
Okay, great. Someone else asked, what is Docker and Docker?
Okay. So Docker is actually Docker image prepared by Docker team that contains a Docker daemon inside. Actually, this is the program that you have inside. You have Docker daemon inside, and it allows you to run multiple Docker daemons on your machine, and each daemon runs in its own container, so it's properly isolated. And it also allows you to, for development and testing environments, not to install different version of Docker on your machine, but actually to run multiple version of Docker using dint images. So you try better version. I can try, 1.12 and 1.10 as dint and 1.13, and they changed the versioning. Now it's a 17 point something. Okay, so actually every release candidate beta, you don't need to install it physically on your machine. You can use dint. You can use dint to create a multiple Docker daemon and link them together into cluster, like Swarm cluster, but actually it's also possible to link them together into Kubernetes cluster if you like. So just regular Docker nodes.
Great, that makes sense. And someone else that wanted to know if this approach will also work on a Linux machine?
For Linux, it will be even easier, since for Linux you don't need these nice packages like Docker for Mac and Windows. For Linux, Docker is already native, and you don't need to create this native feeling. For Linux, it's just a Docker, it's a Docker daemon, regular Docker daemon, so you can use again, start with this daemon and create multiple dint containers and link them together into clusters, or create multiple clusters if you have enough RAM in disk.
Okay. Someone else asked about Codefresh. How does that tie in, and do they support Docker Compose version 3?
As I said, Codefresh currently supports Compose version 2, and we are finishing work on version 3. We are going to support Compose version 3, meaning for you define Codefresh, you can define the CI/CD pipeline with the step. Each step actually is run in its own container, and each step can either create a new Docker image or to execute commands from Docker image, and can also run the composed application and test this composed application with different test utilities. So we supported, till now we supported version 2. Pretty soon we are going to support version 3, and I invite you to try it. It's free for open source project. It's easy to try if you have public GitHub or Bitbucket repositories, and for private repositories we also provide a trial period, so you can trial to your private repositories also. It's very fast. The build is very fast.
Great. And we have another couple of questions here. So how is routing to the services handled?
So routing to the services is a Swarm responsibility. Actually, it's a Swarm answer to DNS requests. So on each node, you try to address the service like you address the remote host using host name, and actually service name become a host name. For example, if you call your service PostgreSDB, so it will be available on every other service like under PostgreSDB name. And Docker Swarm uses internal key value store raft algorithm they implement to synchronize this data. Once you launch service on one node, it knows how it creates a DNS record to reply to DNS requests with proper IP. So actually, when you address some service, you will work against some internal IP, and you have multiple instances of this service. The IP will be randomly chosen, and it's a round-robin algorithm. Basic load balancing.
Great, thanks, Alexei. I think we got to a lot of the questions here. If we didn't get to them all, feel free to reach out to Alexei or myself directly, and we're happy to follow up with you over email and answer any additional questions that you guys have. Let's see. As Alexei said, you know, I definitely encourage you guys to sign up for a free account at codefresh.io and give it a spin. We're working on implementing Docker Compose version 3 and supporting that. So, you know, if you guys have any questions about that, feel free to reach out to us. And if you're looking for additional information on Docker and containers, I would definitely recommend checking out our blog and subscribing to our newsletter so that you can stay updated on future events and webinars that we'll be hosting here. And if you guys have anything else you'd like to ask, feel free to reach out to us at contact@codefresh.io. Great. And unless there's anything else you'd like to add, Alexei, in terms of recommendations for where they can find more information on Docker Compose version 3 or Swarm, is there anything that you'd recommend checking out?
Actually, the Docker team themselves, they have a very good documentation site.
Yeah.
One tip, sometimes if you would like to work on edge technology and see what's going on, I recommend you to go and check Docker GitHub repository. Since even documentation folder, they are markdown files, they are more completed than the documentation you can find on their site, or more updated. So it's worth to, sometimes you find information you cannot find on official documentation, you can find it on GitHub repository. And sometimes also looking into code can help you what's going on inside. Okay, so for example, I was looking at the Docker client and understand that the Docker client actually implemented their own parser of Docker Compose and on the client side, meaning server is not aware about Docker Compose. What's happening, client parse this file and execute each deploy command against server API, creating network services and etc. So I encourage you to go and check Docker GitHub repository.
Yeah, thank you, Alexei. And if you guys have any additional questions, feel free to reach out to us. And thanks so much for taking the time out of your day today to join us. We hope it was valuable. Feel free to leave any feedback or comments for future topics that you'd like us to cover in the survey. And we hope to see you next time. Thank you. Have a great day.
Have a good day. Bye.